Just making sure that we're all on the same page with what we need to do to simplify those things about factoring and then dividing out common factors. So we're going to learn new stuff today. The stuff we do today is not on the quiz on Friday. Just the stuff that we've done since the last test, since the test last week and today, or Monday. So those two sections that we did. All right. So we've talked about in the previous lecture how we multiply and divide rational expressions. So today is just going from multiplication and division over to addition and subtraction. So just to talk about the same idea that we do with division and subtraction, or sorry, for addition and subtraction, sorry, of rational expressions, let's go back and remember how we do addition and subtraction of just fractions to start with, right? So the way these fractions are written, can we combine them together right now? No, what do we have to find? Common denominator, right? So just to go through kind of the long-winded process of finding a common denominator, one way you might do that would be to take the denominators, the things that are on bottom, and factor them, right? So we can write 15 as 3 times 5, and we can write 6 as 2 times 3. One reason why we might do this factoring is because this helps us a little bit for figuring out what a common denominator is. So for example, they both have 3's in them. So do I have to worry about a 3 in all? If they both have a 3 in it? No, that's okay. That's already common, right? But this one has a 5 in it, and this one doesn't, right? Anything that's in one has to be in the other to be able to multiply, or excuse me, to be able to add them or subtract them, because that's how we get common denominators, right? So if there's a 5 in this one, I better put a 5 in that one as well. Okay. This one has a 2 and that one doesn't, so since this one has a 2, I better put a 2 in this one. And the way we do that, of course, is multiplying by 1 in a special way, right? So if I want to put a 2 in the denominator on this one, I would put a 2 in the denominator. I also need to put a 2 in the numerator, right? Right? In the other one, if I need a 5 in the denominator, I also put a 5 in the numerator, don't we? Now notice if we multiply everything back together again, here you get 8 over 30. And this one you would get 15 over 30. And now we can add the numerators and keep the denominator the same. So when we add across, we have 23 on top, and then it'll be over 30. So notice the way that I attacked this. Rather than looking at 15 and 6 and saying, oh my gosh, what's the multiple of both of those things? I factored first and looked at what one fraction had that the other didn't and put it all into one thing, right? The first fraction didn't have a 2 in the denominator, so I put 1 in there. The second fraction didn't have a 5 in the denominator, so I put 1 in there. Okay. We're going to use that same premise when we move from doing numbers to polynomials. Okay? So let's look at this first example that we have at the bottom. I want to add those two expressions together. I want to add the x over x squared plus 10x plus 21 to the 3x over x squared plus 12x plus 27. First off, easy question. Are those two denominators the same? No. So do we have a common denominator? No. So do you think we can add them? No. Okay, good. Those are the right answers. All right? These are definitely not the same denominator in both of those fractions, right? So just like up in the previous, with an example of numbers, if I don't have the same denominator, I can't add them or subtract them, right? Either or. So I need to figure out what a common denominator is that works. And we're going to use the exact same premise that I just used a minute ago and that we've used in the previous sections. We're going to factor. Good news is the only thing I really have to worry about is factoring the denominator. Okay? So let's look at the first denominator. If we look at that first denominator, again, it has a leading coefficient of 1, so that makes it a little bit easier to do the factoring, right? I have to have an x and an x to get an x squared, right? So now we need things that multiply to 21 to give you 10. What do we need to use then? 7 and 3, so we get an x plus 7 and an x plus 3. Okay. Let's do the same thing for the second fraction. How does that denominator factor? X plus 3 and x plus 9? Yeah. I agree with that. Again, to get the 3 and the 9, I need things that multiply to 27 to give us 12, right? Add together equals 12. Okay. So notice again, this first step that we just did is just like the first steps that we've been doing with the multiplication and the division, right? It's just that all I'm worried about now is the denominator, because I need a common denominator. Okay? All right, so again, to make these fractions have a common denominator, I need to make sure they have the exact same factors in the denominator. It's like what we did with the example that we wrote up with numbers. Okay? They both have an x plus 3 in them. So do you think we need to worry about the x plus 3? No. Okay? This one has an x plus 7, so what do you think this one needs? X plus 7. This one has an x plus 9, so what do you think this one needs? X plus 9. Good. So that's exactly what we're going to do, just like we did with the numbers. I'm going to go over here. I need an x plus 9 in the denominator. To keep everything equal, what better we put in the numerator? X plus 9, right? I better keep it equal, right? I can't just multiply by, say, a half, because that doesn't keep things equal, right? I have to do 2 over 2, right? So what do you think we need to multiply the second fraction by? Yeah. And I need it on top and on bottom, right? And you do it in both places to keep everything equal. Okay. So again, we're going to simplify this here in a second, but just to make sure that we're all on the same page. Why did we put an x plus 9 in here in the first one? Yeah, the second one had an x plus 9, right? We need a common denominator, right? The second one had x plus 9 in it, so the first one has to have x plus 9 in it. Why did we put an x plus 9 on top? What does this have to simplify to? To keep everything, it has to simplify to 1, right? To keep everything equal, it has to be a 1, right? Whatever you do on the bottom, you better also do on the top. Okay? Likewise, why did we put the x plus 7 over here? Yeah, because the x plus 7 on this one, and then again we put the x plus 7 on top too to keep everything equal. Okay? But this is why we factor first, so that we can identify what we need to multiply the other one by. Okay? So that we can get that common denominator. All right, so now our job is to simplify. So we'll do this in steps here. So the first one, we would have x times x plus 9 over x plus 7 times x plus 3 times x plus 9. I'm going to write it in the same order. It doesn't matter what the order is. The second one will have a 3x times x plus 7 over x plus 7 times x plus 3 times x plus 9. Remember, when you multiply fractions, you multiply top to top, bottom to bottom. That's all I did there. We have the same denominator now on bottom, so we now can just add across the top, right? So when we add those two together, we'll have x times x plus 9 plus 3x times x plus 7 over the common denominator we found. Okay. Now let's simplify it a little bit because this is a little bit messy. Let's see if we can distribute and combine like terms. When you distribute the x through in the first part, what do you get? Yep, x squared plus 9x. When you distribute the 3x through, what do you get? Good. And then you do not need to worry about remultiplying out your denominator. You can leave it factored. Don't bother trying to multiply those three things together. Okay. And then do you see anything that simplifies on top? Any like terms we can combine? The 21/9 gives you 30x, and then what else? Good. So we'll have 4x squared plus 30x over the x plus 7 times x plus 3 times x plus 9. And you could factor a GCF out of the top if you wanted to, but it's not going to help us with canceling anything, so we'll just leave it there. Is that process okay, what we did? I know it's a little longer than the other ones, isn't it? Okay. All right. Let's do the next one here together. Yeah, the process is a little bit longer. I agree. We'll do this one. We'll do this one together. We'll do a couple on the worksheet together, and then I'll let you practice. All right. Again, our first step, if we're trying to add or subtract, what do we do first? Yeah, you got to factor, right? Factor the denominator. You got to find that common denominator. All right, so let's factor each of our denominators. How does that first denominator factor? Good. So we need, again, since we've got that leading coefficient of 1 here, I just need to look at the negative 40. Since it's a minus 40, I know I need a minus and a plus, right? To multiply to negative 40. And then I need things that multiply to 40 and give me negative 3 when I add them. So I better use negative 8 and positive 5. What about the second fraction? How does that factor? Okay. So we need things that multiply to 30 and give us 11. 6 and 5 work. Good. So we have the x plus 6 and x plus 5. Are we okay with the factoring? I know it's a dirty 6-letter F word, right? It's the second dirty F word, you know, right? Okay. All right. So now the next step, the reason why we factor is because that's going to help us identify the common denominator. So what do we need to see in the denominator for both fractions? What is the common denominator going to be? What's going to be the big denominator that we'll have at the end?
8 plus x plus 5, x plus 6.
Good. Yeah, so I need, since this one has x minus 8 in it, they both have to have x minus 8, right? Since this has x plus 5, they both have to have x plus 5. Since it has x plus 6, they both do, right? So the three factors that we'll see in our common denominator are x minus 8, x plus 5, x plus 6. Every distinct factor that you see has to be in the denominator for a common denominator. Okay? All right, so in order to get that common denominator, what do you need to multiply the first one by? X plus 6. Good. So I better multiply top and bottom by x plus 6, right? Whatever you do on top, you have to do on bottom. Okay? What do you need to multiply the second one by? Good, x minus 8, good. All right, so the first one, 7x times x plus 6. We have x minus 8, x plus 5, x plus 6. The second one will have 4x times x minus 8, and then the same denominator, because it's what we're rigging it to be, right? It was our whole design. We better have the same denominator in both fractions, otherwise we just did a lot of work for nothing. Of course, you might have that opinion anyway, that we're doing a lot of work for nothing. But these better be the same, otherwise you really wasted your time. Okay. Now that we have the same denominator, what can we do? We can combine them and then we can distribute and simplify, right? So combine them first. The whole point of doing that common denominator is that it allows us to just either add or subtract right across the top, right? That's the whole point of doing the common denominator. It just lets us do that, right? Do the addition or the subtraction right across the top. Okay. Now we like to simplify this a little bit if we can. Hopefully we can. What do you get when you distribute your 7x through? Plus. Yeah, it's 42x. Good. I agree. And then what do you get when you distribute the minus 4x to both terms in the second one? Good. Yep, that's right. Good. So when I distribute that minus 4x through, the minus 4x times the x gives us negative 4x squared. Minus 4x times minus 8 makes a plus 32x in that case. We still have the same denominator on bottom. And now final step here, we'll combine like terms. What do we get as our final then when we combine the like terms? It's very quiet. What do you get when you combine the like terms? You have a 3x squared, good. Plus the 74x, good. And then the denominator doesn't change. And again, please, 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 please do not waste your time multiplying out the denominator. Okay? Please don't. You just spend a lot of time trying to get all that multiplied out together. So don't do that. Okay? Leave the denominator alone. Is that okay? Okay. Let's do a couple more of the ones that are on the worksheet together, and then I'll turn you loose. Let's do at least the first three here together. Make sure that we're all on the same page before you work on some more for practice. Let's look at this first one on here. What do you notice about the first one? I already have the same denominator, right? So anything fancy we have to do? No. What are we going to get then when we add those two together? Again, since we have the same denominator, how do we add the fractions? just across the top, right? So what do we get?
7.
Yeah, 7 over, yeah, the x plus 5, right? That's it. That's all we have to do, isn't it? Right? That was like when we did the 8 over 30 plus 13 over, or whatever the heck the numbers were, right? When you add or subtract, the denominator stays exactly the same, right? It doesn't change. We're just adding or subtracting across the top. It's, will they all be mixed fractions? Oh, no, you want to do that. Yeah, no, you just leave it as it is. Yeah. Yeah, you won't have to change anything over to the mixed numbers or anything like that. Is that okay? What about the second one? What do we need to do before we try to add? Okay. Yeah, the denominators are not the same in this case, right? So what do we need to multiply the first one by? X plus 4. And again, whatever you do to the one, you have to do to the other, right? If I multiply the bottom by x plus 4, I have to multiply the top by x plus 4 as well. I have to keep it equal, right? Everything has to stay balanced. What about the second fraction? What do we need to multiply it by? X plus 5 over x plus 5. Good. Or x plus, yeah, this is x plus 5. I wrote 5 instead of the 4. Let me rewrite it a little bit, make it pretty. So the first fraction is x times x plus 4 over x plus 5 times x plus 4. The second fraction is 2 times x plus 5 times x plus 5 over x plus 4. That okay? Now that we have the same denominator, what do we do? Yeah, combine, right? Does the denominator change when you combine them? No. The denominator is exactly the same. What do you get on top? Well, let's distribute afterward, right? Yeah, we'll have the x times x plus 4 plus the 2 times x plus 5, right? The x squared is right. Let's combine them and then distribute, just so that we don't get lost in the shuffle here. Okay. We okay with the combining? Okay. What do you get when you distribute? In the first one you get, okay, and then the second one you get, good. And then when you simplify, you get what? Good. Notice again, once you get that common denominator, it doesn't change throughout the whole problem, right? It stays the same all the way down. The only thing that's going to be changing is your numerator as you simplify things. That makes sense? Work on the next two for just a minute. We'll chat about those, and then I'll let you go crazy on the back of the other problems. So work on C and D. I always want to make sure that we're all on the same page with C and D. And then I'll have you work on the rest of the problems that are on the packet there. Yeah, I'll be right there. Yep, exactly. Bring that down first. Yep. Yep, that's right. Yep. Go ahead and chat about these two, and then, like I said, I'll let you work a little bit more. We got about 10 minutes left of class or so. So let's go over these two together. Make sure that we're all on the same page with these two. And then, like I said, I'll let you go ahead and continue on the other ones. So for part C here, what did you do first? Yeah, we factor that first denominator, right? Not a lot of factoring we can do in that second denominator. It's just an x plus 4. So how does that first denominator factor? Good. X plus 2 times x plus 4. Are we all okay with that factoring? Okay. Now again, looking at these two fractions, let's look at the x. Do I need to worry about the x plus 4 at all? No, because it's already in both fractions, right? So I don't need to do anything with the x plus 4s. Right? We're good there. However, this one has an x plus 2 in it, so what do I need to do to the second one? Yeah, I got to multiply by that x plus 2 over x plus 2, right? So we don't have to do anything to the first one. But the second one we want to multiply by x plus 2 over x plus 2. Okay. So all I did there from this step to this step was just multiply the tops and bottoms, right? Now that we have the same denominator, what can we do? Combine the tops, right? Good. Remember again, once you find that common denominator is going to stay the same throughout the rest of the problem. Okay? You don't have to do anything else with it. So the first numerator is 3x minus 5. The second one is that x plus 7 times x plus 2. And then let's tidy up the top. How does that, when you distribute those, the second two pieces there, what do you get when you distribute this out? Good. Right, do the x times the x times the 2, 7 times the x, 7 times the 2, right? Do all those distributions. Combine our like terms. We have an x squared, we have a 3x plus a 2x plus a 7x gives us 12x minus 5 plus the 14 gives us plus 9. So we get x squared plus 12x plus 9 on top. And like I said, the denominator stays the same. You don't have to worry about that. Questions on that one? The second problem looks very, very similar, right? It's just a minus instead of a plus. First step again is to do what? Factor. Good. How does that factor in the denominator there? Good. Exactly right. X plus 6 times x plus 3. It's exactly right. The second one, nothing to do there, right? There's no factoring to do. What do we need to do next?
Just multiply the right side by x plus 3.
Good.
I'm talking about.
Good. That's exactly right. Fantastic. Both of them have x plus 6 already, so do I need to bother with that? No. I've already got that in common, so I don't need to worry about it. This one has an x plus 3 in it, so this one needs to have an x plus 3 in it. So yeah, that's exactly right. We need to take that second one and multiply it on top and bottom by x plus 3. Oops. And I'm probably putting more steps in here that you actually have to do. I'm just trying to make sure that we're all on the same page as we're going along here. So your second term becomes x plus 4 times x plus 3. Make sure that all gets multiplied together. And then it still has the same denominator. Now that we have the same denominator, what can we do? Combine them. Good. So again, once we find that common denominator stays the same all the way through the problem. We're just going to subtract the tops now. And then again, we should simplify a little bit. The only thing we have to worry about in this problem that we did not have to worry about in the previous problem is that I got to make sure this minus sign gets distributed to everything too. We're done. Okay. All right, so when we do the and so just to emphasize that, let's distribute first. Let's do the multiplication first. What do you get when you multiply x plus 4 times x plus 3?
X to the second power
Mm-hmm.
plus 3x plus 4x plus 4.
Good. So all I did from this step to this step was the multiplication. I didn't take care of the minus sign yet, right? This was just multiplying x plus 4 times x plus 3 to give us this. Now let's distribute that minus sign through. We're almost done with this one. Make sure that minus sign gets distributed to everything. And now when we simplify, we've got minus x squared. There's the only x squared term we have is that one. 2x minus 3x minus 4x gives you what? (2x minus 3x gives you negative 1x minus another 4. So minus 1 minus 4 gives us minus 5x. Plus 1 minus 12 gives you plus 1 minus 12 gives you something silent apparently. 1 minus 12. Negative 11. Good. And then x plus 6. X plus 3. Okay. Any questions on that process at all? All right. So Friday, because we only have about 4 minutes left. Friday we'll practice more of these. Okay. Same stuff. We're not going to do anything new on Friday. Okay. We're going to practice more problems like these. We will also have our quiz at the end of the hour over simplifying rational expressions. That's 14.1. And multiplying and dividing rational expressions, 14.2. Okay. This stuff that we just did today is not on the quiz. Okay. Just simplifying rational expressions and multiplying and dividing rational expressions. Okay. Oh yeah, it's okay. Yep. All right. Well, have a good one, everybody. We'll see you on Friday. What we got? Let's see. Factors. Yes, that one. Square. right to me. We'll go double check it. Yeah, you can do that.